2. Properties of fluids. Welcome to the next step of your fluid mechanics journey, understanding the properties of fluids. Before we can analyze how fluids move, we must first understand what makes them unique. Just like people have characteristics like height, weight, and personality, fluids have properties like density, viscosity, and surface tension that define their behavior. Knowing these properties allows us to predict how fluids will react in different situations, from simple water flow in a pipe to complex aerodynamic forces on an aircraft. This section will give you a strong foundation to confidently tackle more advanced fluid mechanics topics later on.
When you begin studying fluid mechanics, it's easy to jump into equations, but it's smarter to start with the basics, understanding fluid properties. These properties tell you how a fluid behaves before you even think about flow. A good way to remember is this: intensive properties like temperature or pressure don't depend on how much fluid you have, while extensive properties like mass or volume do. Always pay attention to key terms like density and specific gravity. They're the backbone of fluid calculations. As you go deeper, remember to also grasp important behaviors like vapor pressure, viscosity, surface tension, and compressibility. Knowing these will help you solve problems faster and with more confidence.
2. Keep core definitions simple and sharp. When talking about fluids, 3 terms will come up again and again: density, specific volume, and specific gravity. You want to keep these definitions short and crystal clear. Density simply tells you how much mass is packed into a certain volume. It's mass per unit volume. Specific volume flips that idea. It tells you how much space a certain mass takes, so it's just the reciprocal of density. And specific gravity makes life easier by comparing density to a fixed reference, which is water at 4 degrees C. By remembering these 3 terms, you'll avoid confusion later when dealing with complex fluid mechanics problems. Master the basics, and the rest gets easier.
3. Keep gas relationships simple. When it comes to gases, the simplest and most useful tool is the ideal gas equation. It connects pressure, temperature, and density into one clean relationship. You don't need to memorize complicated details. Just remember this rule: low pressure and high temperature make gases behave ideally. That's why the equation works best in these conditions. If you ever feel stuck, just think about balloons. When you heat them, they expand. Pressure changes, and that's the ideal gas law in action. Use this shortcut to quickly understand how gases will behave in most basic engineering problems.
4. Explain the hidden dangers clearly. Let's talk about 2 terms that can quietly destroy machines: vapor pressure and cavitation. Vapor pressure is simple. It's the point where a liquid wants to become vapor. But here's the danger. When pressure in a pipe or pump drops below this vapor pressure, bubbles form, and when they collapse, they release intense energy. This is called cavitation. It's like tiny explosions happening inside your pipes, turbines, or propellers, leading to pitting, noise, and expensive failures. Always remember, cavitation is silent damage until it's too late. Knowing these 2 concepts can help you design safer, longer-lasting systems.
5. Simplify energy concepts for faster understanding. Energy in fluids comes in simple forms. Don't overcomplicate it. You only need to track 3 types: internal energy from molecular motion, kinetic energy from movement, and potential energy from height. That's it. Enthalpy just combines internal energy with flow energy. Think of it as total usable energy. Finally, specific heats tell you how much energy you need to change temperature, either at constant volume or at constant pressure. For most liquids and solids, you can safely assume Cp and Cv are nearly the same. These shortcuts help you cut through the clutter and quickly solve energy balance problems.
6. Simplify how fluids respond to pressure and temperature. When fluids get squeezed or heated, they behave in predictable ways. The coefficient of compressibility tells you how much a fluid shrinks when you apply pressure, like squishing a sponge. The volume expansion coefficient shows how much a fluid expands with temperature, like air inside a hot balloon. For speed-related problems, remember the speed of sound depends on temperature and gas type. And to quickly classify flow, just use the Mach number. Below 1 is subsonic, at 1 is sonic, and above 1 is supersonic. Focus on these key numbers to cut through complicated problems with ease.
7. Explain viscosity in a way that sticks. Viscosity is just a fancy word for thickness or resistance to flow. Honey has high viscosity. Water has low viscosity. Easy. Newtonian fluids are simple too. Their resistance is proportional to how fast you move them. Think of kinematic viscosity like a normalized version. It adjusts viscosity for fluid density. Remember this temperature rule. When liquids get hotter, they flow easier, so viscosity drops. But gases behave differently. Their viscosity goes up with temperature. Keep these patterns in mind and you'll never get confused when tackling fluid flow problems.
8. Explain hidden fluid behaviors simply. Surface tension explains why droplets form and why some insects can walk on water. It's just the force acting along a liquid surface. Capillary effect is even more fun to see. In a narrow tube, water climbs up while mercury sinks down. Why? Because of wetting. Water likes sticking to surfaces while mercury repels them. You don't need to memorize complicated math. Just remember, water rises, mercury drops. This simple rule helps you quickly predict liquid behavior in narrow spaces like tubes or porous materials. 9. Summarize key fluid properties with confidence. Before moving forward, take a moment to lock in the big picture. Always start with density and specific gravity. They form the foundation of fluid behavior. Remember vapor pressure when thinking about boiling or cavitation problems. Energy and enthalpy help you track heat and flow work. Compressibility and speed of sound show you how fluids respond to pressure waves. Viscosity tells you how much a fluid resists motion, while surface tension explains droplets and capillary action. Keep these 6 ideas clear in your mind, and you'll be ready to handle real-world fluid mechanics challenges with ease.